Okay, in this video we are beginning a new unit on polynomials, and it's going to be 10.0 for this lesson. Identifying polynomials by degree and number of terms. So by the end of the lesson, that's what we're going to do. We're going to look at some terms and we'll be able to figure out what they are by degree and by terms. You need a little bit of vocabulary up front. There is this word called monomial, and monomial means, or mono means one, and a monomial is a number like 8, a variable like just x right here, or the product of a number and one or more variables. The product, for instance, the product down here, multiplication is happening between 3 and x squared and y. So there's two multiplication operations right there. There's one right there. There's one right there. You might remember coefficient. The coefficient is a number times a variable. So a number, a variable, or the product of a number and one or more variables with whole number exponents. Let's look at the exponents on all of these examples here. And this is an exponent of 1. Also 1, 1, 1, 2. 1/2 is to the first power. Y to the first power, 2. Notice all of these are whole numbers. All the numbers on the right side of the 0 sign. No negatives. So a non-example would be like 3 to the -1 power here, and x to the 1/2 power. We're not going to work with a fraction in the exponent position or negative exponent at this time. Everything is going to be, we'll be working with this. But a monomial, these are all one terms, meaning I am not, for instance, I'm not doing this, x squared plus x. As soon as I have that addition right there, then I don't have a monomial anymore. Another piece of vocabulary for you. Degree of a monomial. I'm going to need you to figure that out. And what that means is that is the sum of the exponents. So we're going to be doing some adding. Some of the exponents of the variables in the monomial. So we are only going to add the exponents of the variables to find out the degree of a monomial. So for example, 3x squared, in this particular case, I'm only looking at the variable and I'm looking at the exponent of the variable. The degree is 2. So this is a monomial with degree 2. Down here, this would be, I have a 2 and a 1, so the degree is 2 plus 1. Remember sum, 2 plus 1 equals 3. This is a degree 3 monomial. Over here, if I had something like -6z to the 4th power, you guessed it, I only look at the variable here and the exponent of that variable, and it would be 4. Look at this here, number 7. This actually, it does not have a variable, so the answer to this is 0. The degree is 0 because there is no variable in this monomial. So let's do an example. Find the degree of a monomial. In A, I have -5x to the 4th power. I know the degree is going to be 4 because I look for the variable and then I look for the exponent, and simply this is to the 4th power monomial. For B, I have 1/2 b to the 3rd power, y to the 2nd power. And you may remember from the first page, I look at the variables and it's the sum of the exponents. So we're going to add 3 plus 2, and that's where we get 5. This is a degree 5 monomial. And here we have this option again, 12 there's no variable, so the degree is 0. There is no degree for a monomial that's only a constant. All right, your turn right here. So I want you to pause it, and I want you to come back and see if you did it right. I'm going to go ahead and start doing it right now, though. Looking at the degree here on the first one, I look at the variable, the exponent, and the degree will definitely be 3. Right here I have a 4. Basically I have a coefficient and a variable, but I just look for the variable and the exponent is 1. My degree is 1. Here I have in number 3, I have an x to the second power and a y to the third power. I add those up. 2 plus 3 equals 5. That's the degree of that, 5. And here I have a lot of variables, 3 of them. But I just look for the variable and I look to see what the exponent is. I'm going to add them all up. So 2 plus 2 plus 2, 6. 6. That monomial is to the 6th degree. Easy peasy. Okay, now we're going to start talking about a polynomial. The vocabulary here, the word polynomial, poly meaning many, and if you remember the monomial was one term, well poly is going to be obviously many, so 2, 3, 4, however many we're going to have. Polynomial, well it's a monomial, or, so it can be one term, or a sum of monomials. So that means I could have a term here, term here, term here, and I could add them all up, and I will have, that's also a polynomial. But if you look here, so what is it really going to look like? Here's a monomial, x squared, that also fits a monomial as part of the definition. Another monomial, still a polynomial, and or 5, still a polynomial. I have 3 polynomials, or a sum, which means I'm just going to see if I can write left-handed here, and a sum of monomials, which that also, now I have x squared plus 4x plus 5. That's a polynomial. Also, a little cloud over here for you to remember. It needs to be written in standard form. What does that mean? That means the exponent with the highest exponent goes first, the next highest goes second, and constants are always in the back of the bus. So, some examples here. I want you to be able to tell me what kind of polynomial it's going to be, and this is what we're going to do with this one here. We're just going to figure out what kind of polynomial is it. This 4x to the third power, that is a monomial because it's only one term. Another example would be x to the third minus 8. Now I have 2 terms, and these are called binomials. Whenever I see this right here, I just look at that and I instantly think binomial. 2 terms, bi means 2, single term, mono. And then you've got 3 terms in here, 7x squared minus 4x plus 6. You guessed it, trinomial because it has 3 terms. Do they go on more than that? Yes, they do. So it could have however many terms we want in there. It can, and I forget the list, but we're going to learn it in class. All right, next slide. So, example 2. What I want you to do is I want you to be able to identify polynomials. And I want you to be able to identify them in 4 fashions, or 4 different ways. Polynomial, their degree, identified by the degree, and identified by the number of terms. So, if I look at A, number 6, there's no variable, so I know the degree is 0. I also know that that number is called a constant, so that's how I would identify it by a degree. Well, because it's 0, it's a constant for sure. And then this last part here, identified by the number of terms, well, it's only one term, so that's a monomial. In B, I've got 3x plus 1. I look at the variable right here and see that it's a power of 1, so my degree is 1. It's linear. Remember, how did I know it's linear? Remember that as long as the variables are to the power of 1, we're going to have a straight line. And then also I have 1, 2 terms. So the number of terms, this is a binomial. First one was a monomial, this is a binomial. 1, 2, 3 terms, trinomial. This is called a quadratic because if you remember from the last few lessons, we were dealing a lot with x squared. And when the leading term has a degree of 2, that will be called a quadratic. So the degree is 2 from here. Now you might be looking at this and this going, well, why isn't it 2 plus 1 and that's 3? Remember, the degree is based on a monomial. It's based on one term and the highest in the polynomial. So the highest degree monomial in here is this negative x squared. That exponent is higher than that one. Therefore, he gets all the credit. He gets the name. He gets the identification. So this is just a second degree, known as a quadratic. Also, because of the 3 terms, known as a trinomial. This last one here, 4x cubed minus 8x. Well, that degree will be 3 because of the highest monomial right here has a degree of 3. Also known as a cubic. You might remember that with your volume problems. And this is a binomial because it only has 1, 2 terms. It's all right. I could have a degree of 5 or 10 or whatever. This is based on how many terms do I see right there. Okay, time to pause again, and it's time for your turn to knock this out. Identify the polynomial by degree and number of terms. I just have 4 quick ones here for you. I want you to try on your own, and then come back and watch how I do it. Number 5, right here, I'm looking in this area, and I just know the degree equals 1. How many terms do I have? Just one term. One term equals monomial. Number 6, I look at for the variable in this whole quantity. I only see 1 there, so the power is 1. I have 2 terms, 10x and negative 5. And so this qualifies as a binomial. Number 7, I'm looking here, I see a x to the first power, x to the second power, but in the whole polynomial here, it is leading with the highest degree. So this is a degree 2. This is 3 terms. So therefore, this is a trinomial. And the last one, I've got 2 terms here. Let's put now. I went backwards on you on purpose because remember, you want to put this in standard form. So change it around so that it's in standard form. This is a negative x to the 3rd power minus 24. And I put the highest exponent in the top, so this is in standard form, highest exponent, and the constant, remember the constants are always the last thing that we see or we read. So therefore, this is to the 3rd power. Degree equals 3. That's the only it's the only variable that I see, so that's it. And this has 2 terms. And 2 is called a binomial. And that is identifying polynomials by their degree and by the number of terms that they have.